Hello, this is a demo video for the usage of the tool Aerialist. Before going through this video, you need to have the environment set up as detailed in the documentation on GitHub. After that, you can use the command line interface in a few different scenarios that we will show uh, today. Uh, the first one is running some manual flight test. This means commands that are coming from a remote control. The first test, we are using the local agent, meaning that we are running the tests in the simulation on our local machine. This way we can have direct access to the simulator and see the drone while flying. Uh, After executing the command line, we will see the simulation environment being set up. Um, we will see the gazebo window showing up. Then the drone, the commands are being scheduled to send to the drone. The drone takes off, maneuvers in different directions, and then lands. Uh, After the test finishes, we will have the flight log and the flight trajectory plotted in our results folder. The next test case would be running the exact same test, but this time using the Kubernetes agent. So what's different is that we are running the test cases not locally, but in a Kubernetes cluster. Here we have a Rancher cluster set up, and then we are running 5 parallel simulations in 5 separate pods in the Kubernetes cluster. And the whole execution is translated into a Kubernetes job. For sharing the files that as inputs and output files, we use a Nextcloud instance to share the file. When you run the command line, you will see a Kubernetes job and with 5 different runs in parallel. If you go into the logs of each of them, you will see the exact same logs that you saw locally a few minutes ago. After the containers finish and the simulation is done, you will have the flight log of each of those 5 runs in the Nextcloud, and then they are downloaded on your local machine, and you will have the plots also there. The next test that we will run is a mission or autonomous flight. This time we are using some predefined missions, and then we are putting some obstacles on the map. The goal is to here to test the obstacle avoidance feature of PX4. Um, at the moment, we are using the Docker agent. This means running the test cases locally, but inside the Docker container. When you run the command, you will see a Docker container being initialized on your local setup. And then the test is being executed and simulated inside that Docker container on your machine. As you see, it's taking quite high usage of the CPU because it's a vision-based algorithm for obstacle avoidance, and it takes quite some resources in comparison to the manual flight. When the test finishes, as before and with all the other agents, you will have the flight log of the executed test cases and the flight trajectory plotted in your results folder. Uh, Using the Docker usage um, lets us run the test cases on our local machine without needing to install every dependencies like px4 avoidance, and everything. This is the best and recommended way for beginners to use the tool. Uh, the next test case that we will show is running the exact same test case, the autonomous flight, this time in the Kubernetes cluster. So as before, we are running 5 times in parallel the same test case, and it's been translated into Kubernetes job with 5 executions, and the files are being shared over a Nextcloud instance. So when we run the command line, we will see the files copied to the Nextcloud, then shared with the new Kubernetes job that we have. You see 5 parallel pods are running, each of them running a separate simulation. And the same commands that the same behavior that we could see before in the Docker execution is happening this time in the cloud. These are the inputs files to the test. Then, when the tests are finished, the flight logs will be copied by the simulation containers to the same folder. Let's wait a bit until all the executions are done. So now 3, 4, and 5 simulations are completed. If we check the Nextcloud, we will have now 5 flight logs, 5 ulogs there. All of them are downloaded and then plotted here. As you see, there are a couple of differences in each runs. That's why Kubernetes is a good way to test when we have tests that have varied trajectory over different runs, as you see the difference between 1 and 5 runs. Thank you for the latest documentation and examples. Check the GitHub repository.